Welcome back, students. In this video, we're going to cover lesson 7.2, similar polygons. This is going to feel like we've done this lesson before because it comes out of module 8. They pulled it and put it in module 7 because it's, we were talking about triangles and this goes with quadrilaterals, so they kind of pulled it out. So, and if you were in class when we went over similar triangles, then some of this will make sense. It's basically the same thing, just adding an extra side. But let's get started. So let me see. All right. So in the same way as similar triangles, like I was saying, two figures are similar polygons if one can be obtained from the other by a dilation or a dilation with one or more rigid transformations. So over here, they're taking this triangle and they're going to reflect it in an imaginary line so that it comes down here. Then they're going to translate it over to here, and then they're going to dilate it so it gets bigger. Remember, dilation's not, it's bigger or smaller, but in this case, dilation was bigger. So they reflected to get down here, they translated over here, and then we ended up with these are similar triangles because you can get from here to this by these transformations and then the dilation. All right. So two polygons are similar only if all their corresponding angles are congruent and all their corresponding side lengths are proportional. So just like with the triangles, the angles will be the same, the sides will be in proportion. Obviously, again, more sides, but they all have to be congruent, all have to be in proportion. So if they give you a figure and you can tell that the angles are not all congruent, then you can go ahead and tell it's not similar. If the angles are all congruent, then you have to check the proportions. Okay. So here our example over here. So ABCD goes with PQRS. So ABCD, PQRS, and they show that A goes with P, B with Q, C with R, D with S. I usually will write it like this. So ABCD, PQRS, and then it's these two, and then these first two, second two, last two, and then first and last. So all these letters go together. See, first two, AB, PQ, BC, QR, CD, RS, and then DA. So last first or first last, DA, SP. And then AP, BQ, CR, DS. So they just all go together just how it's written. All right, another way is the congruent marks. So it tells us here, but N has one green. I don't know if you can see on the screen the color. It's really weird. But these two go together, and then these two go together. So NPQ, RST, N and R, Q and S, and then P and T are both blank. So we have congruent angles. If two of a triangle are congruent, the third has to be. So our angles are good. Now they want to know, are they similar, or you're finding the scale factor. So we're going to go, so NQ, first two letters goes over RS. Oops. So we got 12.5 over RS is 10. Let's see. NP, that's 15. It's going to go, so MP first and last, RT first and last, so 12. And the last one, so we had 12.5 to 10, 15 to 12, and now it'll be 11.5 to 9.2. So QP, second and third letter, to ST, second and third letter. All right, so we divide these out. You'll get 1.25 for these. This is 1.25. And this is also 1.25. Now, from from here to here, so this is new over old. I did this backwards, so your scale factor, instead of 1.25, it's going to be 10 over 12, which is 0.8. So my bad there, but yes, triangle in QP is similar to triangle RST. All right, so now you're going to do the practice over here. So A, B, C, D to E, F, G, H. So you notice they're all the angles are congruent. So you're just looking at the sides. They want to know if they're similar, and then the scale factor. In this case, so it says similar. So there's no from, but this is the old, this is the new. Scale factor is new over old. So just a little help with that. All right, example 2 at the bottom. Ooh, sorry about the movement. So in the diagram, WXYZ is similar to PQRS. Find the value of Y. So they're telling us it's similar. So these will be in proportion. So let's see. We got ZY and RS. So ZY is 5Y minus 2. This pen is, let's just change it out. So 5Y minus 2. And then over here we got 6. And then, so WZ, so first and last PS. So 16 over 12. So this over this, and then this guy over this guy. We started here. Both of these are on the top, both of these are on the bottom. Now we're going to cross multiply. So 6 times 16 on one side, and then 12 times 5y minus 2 on the other side. All right, so 16 times 6. 96. 12 times 5y is 60y, and then 12 times negative 2 is negative 24. All right, so we want the 60y by itself, so we're going to add 24 to both sides. Going to give you 60y equals, these cross out, this will be 120. We're going to divide both sides by 60. So our y is going to be equal to 2. This 120 divided by 60 is 2. All right, flip it over. Practice 2. So right here, you're going to do the same thing. So JLM, QST. So we're going to match them up and cross multiply because they're telling us it's similar, so we can find X. So that's for you guys. Example 3 I'm going to do, and then example 4 you guys are going to do. And I'm sorry, practice 3, and then example 4 is at the bottom. We're gonna do it. So okay, and you know, I'll be honest with you guys, we've talked about this in class. This is not my strong suit, but we're gonna work it anyway. So are these guys similar? If so, what composition of transformations maps this guy onto this guy? So the first thing I look at is how far apart. So I see the 1, 2, 3. So it's 3 away. So if we were to go halfway, that would, you see 1, 2, 3, we would go halfway in between. I'm going to draw a dotted line. Not straight, and I apologize. Now this is negative 1. So this is X equals negative 2. So we could reflect that. So that would put point P here, point R here, and point, but see, point Q is 1, 2, so it's further away. And that tells me this is likely not similar, but let's try it anyway. So again, here, here, and then this guy would be here. But I'm telling you, this is where it gets dicey. So draw here, color it in. So we move from there to there. We've reflected over. So now if we were to expand out, now I'm going to write the coordinates we started at were 0, 3. Actually, 0, 1, 2, 3. This is where it, after we reflect. Sorry, R is 0, 1. See, 0, 1. And then Q is like 1 and 0.5, or 1 and then a half up. See, we went over 1 and up about a half. So where these new points are at, 0 and 4, z is 0 and 0, and then y is positive 2, negative 1. All right, so we look here and we say, all right, is there anything we can multiply by? Well, if I multiplied 3 by 1 1/3, it would give me 4. But if I multiplied, there's nothing I can multiply here to get 0, 0. There's nothing you can multiply here. So, like I said, that it should be equal. These were equal, but this guy was not, and they're not similar. So, not similar. So, these are not similar, and it's because the sides are not in proportion. So, sides not in proportion. Sorry, we slipped off the page there. Okay. I can tell you, I'll just give you a hint that these two are going to be similar. And it's 2 steps to get from here to here. Notice if you just look at, this is 1 by 2, this is 2 by 4. So you can kind of decide from there what the k factor is, and then it's gonna, it moves. It's not gonna reflect or anything out. That's your hint. It moves or translates, and then it dilates. So there's your, for those of you that are listening and watching the video, not just taking the notes. Okay, example 4, we'll finish up. This is gonna be super quick because we're not even gonna have to look at the sides. So we have 2 angles that are congruent. Now remember, so this is 4 sides. So n minus 2 times 180, that's 4 minus 2, or 2 times 180, which is 360. So the total for these angles is 360. We have 90 and 90, so that's 180, right? So 360 minus 180 makes 180. So that means these 2 guys together have to be 180. So 180 minus 133, that is 47. See, 47 is not equal to 41, so these are not similar. And it's because the angles are not, we'll just do like that, not congruent. Okay? All right, that's it for this video. If you have any questions, please let me know. Send me a message on Teams or on Focus. You're also welcome to comment, especially you guys that have stumbled onto the channel just through searching. Welcome. Feel free to comment. I'll be glad to explain more if I can. Please consider liking and subscribing. Until next time, have a good night.